Now we're on the second half of page 7 of the chapter 14 AP Chemistry packet, and we're going to talk about what happens to find the pH of a mixture of strong acids. So we're going to mix two strong acids. We're mixing HCl with HNO3. Because we have strong acids, we're not going to need to do any ice calculations at all. So we're going to start with the HCl. They're both equal, so there's no real rhyme or reason to whichever one you want to start with. So we'll just write the HCl since it was first in the problem. So here's your beaker of HCl. This breaks up 100% into H plus and Cl minus. You have 1 molar solution and you have 0.300 liters, which is going to be 0.300 moles. Then that was the hydrochloric acid. This is the nitric acid. You also have a strong acid, so that breaks up 100% into H plus and NO3 minus. Here you have a 2 molar solution. You have 500 milliliters, so 0.500 liters, and that's going to give you 1 mole of the nitric acid. So now the question is, what happens when you put these two together? What happens when you put this all in one big beaker? So to find the concentration of each of these, you're simply going to do molarity equals moles over liters. So I'll do the concentration of H plus by itself here. That's going to equal, of course, the moles of H plus over the liters of H plus. And then we're going to have two other ions that we could find. We have the chloride ion. That's also going to equal moles over liters. And we have the nitrate ion, which again equals moles over liters. So if you take a look at this, you can see that the total volume is going to be the sum of these. You'd have to assume that the values of volume are additive, so that's 0.800 liters total. So that's going to go over here for all of these calculations. Now we just need the moles of everything. So the total moles of H plus are going to be all the H pluses from here and all the H pluses from here. And so if there's 1 H here, then it would be 0.3 times 1 plus 1 times 1. So that's going to give you a total of 1.3. And you'd write that here for the H plus moles. Then when you do the math for this, you should get 1.63 molar. All right, next we're going to have the Cl minus. So Cl minus came from the hydrochloric acid. We have 0.3 moles, and there's just 1 chloride in every HCl. If this had been Cl2 for some reason, like HCl2, then this would have been 0.3 doubled. Okay, but there's only 1 chloride, so it's just 0.3. That would hold true for any of the ions. So then if you do the math for this, you're going to get 0.375 molar concentration of chloride, and the concentration of the nitrate is going to be 1 mole, again because you have 1 nitrate and you have 1 mole of the nitric acid, and you divide this and you're going to get your final concentration to be 1.25. So when you mix two strong acids, they're both strong, doesn't matter with which one you start because they're both the same, and there's no ice calculations at all. You just do molarity equals moles over liters and then get the total moles of each ion over the total liters of both solutions and find each of your molarities.